For a 500 amp service with 9 meters fed from a main disconnect and using 2 masts running in parallel, it is permissible to run 2 parallel grounding electrode conductors to the water main according to the 2020 National Electrical Code. Section 250.66 Code of the National Electrical Code addresses the requirements for parallel grounding electrode conductors. It specifically states that for parallel grounding electrode conductors, they must be connected together, and both must be connected to the grounding electrode in the grounding system. Furthermore, the parallel grounding electrode conductors must be of the same material and size to ensure equal current distribution and proper grounding function. Since the scenario involves a 500 amp service and the installation of 9 meters, the minimum size requirement for the 2 parallel copper grounding electrode conductors is 250 kcmil. This size is determined based on the largest service entrance conductor size, as per the National Electrical Code guidelines. It is imperative to connect both 250 kcmil copper grounding electrode conductors together before connecting them to the water main. This connection ensures that the grounding system functions effectively and provides a low impedance path for fault currents. The selection of the appropriate size for the grounding electrode conductor is crucial for safety and compliance with electrical codes. The National Electrical Code provides tables and guidelines to determine the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The purpose of the grounding electrode conductor is to connect the electrical system to the earth, providing a path for fault currents to flow back to the source. This path allows overcurrent protection devices, such as circuit breakers or fuses, to trip and de-energize the circuit, preventing electrical shock and fire hazards. In the case of parallel grounding electrode conductors, it is essential that each conductor is sized adequately to handle its share of the fault current. The National Electrical Code requires that parallel conductors be of the same material, size, and length to ensure that they share the current equally. When installing parallel grounding electrode conductors, it is crucial to follow the manufacturer's instructions for the connectors and terminations. The connectors must be listed for use with the specific size and type of conductor being used, and they must be installed properly to ensure a secure and reliable connection. The grounding electrode system should be installed in accordance with the National Electrical Code and any local amendments. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the electrical system to the grounding electrode, providing a path for fault currents to flow to the earth. It is important to protect the grounding electrode conductor from physical damage. The National Electrical Code requires that the grounding electrode conductor be installed in a location where it is not subject to damage, or it must be protected by a suitable raceway or enclosure. The National Electrical Code also requires that the grounding electrode conductor be continuous and without splices or joints, unless specifically permitted by the code. Splices and joints can increase the impedance of the grounding path and reduce its effectiveness. In addition to the grounding electrode conductor, the National Electrical Code also requires that all metal enclosures and equipment be grounded. This grounding provides a path for fault currents to flow back to the source, protecting people from electrical shock hazards. The equipment grounding conductor is typically a green insulated wire that runs with the circuit conductors. The equipment grounding conductor is connected to the metal enclosure or equipment and to the grounding terminal at the electrical panel. The equipment grounding conductor must be sized in accordance with the National Electrical Code and must be installed properly to ensure a secure and reliable connection. Proper grounding is essential for the safe and reliable operation of electrical systems. The National Electrical Code provides comprehensive requirements for grounding electrical systems, and it is important to follow these requirements to protect people from electrical shock hazards and to prevent fire hazards. Always consult with a qualified electrician or electrical engineer to ensure that the electrical system is properly grounded and meets all applicable codes and regulations. Understanding the requirements for grounding electrode conductors, especially in parallel configurations, is critical for ensuring the safety and reliability of electrical installations. The National Electrical Code serves as the primary reference for these requirements, and adherence to its guidelines is essential for compliance and safety. When dealing with parallel grounding electrode conductors, remember that both conductors must be connected together into the grounding electrode, and they must be of the same material and size. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, and the National Electrical Code provides tables to assist in this determination. Proper installation and connection of grounding electrode conductors are crucial for providing a low impedance path for fault currents and ensuring the effective operation of overcurrent protection devices. In conclusion, the use of two parallel grounding electrode conductors to a water main is permissible for the described 500 amp service with 9 meters, provided that the installation adheres to the 2020 National Electrical Code requirements outlined in Section 250.66 Cone, including the proper sizing and connection of the conductors. The selection and installation of grounding components should always be performed by qualified personnel with a thorough understanding of electrical codes and safety practices. In addition to the general requirements for grounding electrode conductors, there are specific considerations for installations in different types of buildings and environments. For example, in corrosive environments, it may be necessary to use grounding electrode conductors made of corrosion-resistant materials such as copper-clad steel. Similarly, in areas with high soil resistivity, it may be necessary to install multiple grounding electrodes to achieve the required grounding resistance. The National Electrical Code provides guidance on these and other special considerations for grounding electrode systems. It is important to consult the National Electrical Code and other relevant standards to ensure that the grounding system is appropriate for the specific application. Furthermore, it is important to inspect and test the grounding system regularly to ensure that it is functioning properly. The grounding resistance should be measured periodically to verify that it is within acceptable limits. The connections to the grounding electrode should be inspected for corrosion or damage. Any problems with the grounding system should be corrected promptly to maintain the safety and reliability of the electrical system. In addition to the National Electrical Code, there may be local codes and regulations that apply to grounding electrical systems. It is important to be familiar with these local requirements and to comply with them. Local codes may have more stringent requirements than the National Electrical Code, or they may address specific issues that are not covered by the National Electrical Code. Failure to comply with local codes can result in fines, penalties, or even the shutdown of the electrical system. Grounding is an essential aspect of electrical safety, and it is important to take it seriously. By following the National Electrical Code, local codes, and other relevant standards, you can ensure that the electrical system is properly grounded and that people are protected from electrical shock hazards. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about grounding electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional advice. It is essential to consult with qualified professionals for specific applications and to ensure compliance with all applicable codes and regulations. Remember, electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Always follow safe work practices and use appropriate personal protective equipment when working on electrical systems. Grounding is not only a matter of safety but also a matter of performance. A properly grounded electrical system can improve the reliability and efficiency of electrical equipment. Grounding can reduce electrical noise and interference, which can improve the performance of sensitive electronic devices. Grounding can also help to protect electrical equipment from damage caused by lightning strikes or other electrical surges. A well-designed and properly installed grounding system is an investment in the safety, reliability, and performance of the electrical system. In addition to the grounding electrode conductor, there are other important components of a grounding system, such as the grounding electrode, the bonding jumpers, and the equipment grounding conductors. The grounding electrode is the physical connection to the earth, and it can be a ground rod, a metal water pipe, or a concrete encased electrode. The bonding jumpers are used to connect metal parts of the electrical system together, such as metal conduits, metal enclosures, and metal equipment. The equipment grounding conductors are used to connect the metal parts of the electrical system to the grounding terminal at the electrical panel. All of these components work together to provide a low impedance path for fault currents and to protect people from electrical shock hazards. The grounding system should be designed and installed by qualified professionals who have the necessary training and experience. The grounding system should be inspected and tested regularly to ensure that it is functioning properly. Any problems with the grounding system should be corrected promptly to maintain the safety, reliability, and performance of the electrical system. Grounding is a complex topic, and there is much more to learn than what is covered here. However, by understanding the basic principles of grounding and by following the National Electrical Code and other relevant standards, you can help to ensure the safety and reliability of electrical systems. Always consult with qualified professionals for specific applications and to ensure compliance with all applicable codes and regulations. Electrical safety is everyone's responsibility, and it is important to take it seriously. By being aware of the hazards of electricity and by following safe work practices, you can help to prevent electrical accidents and injuries. The 250 kc mil copper grounding electrode conductors must adhere to conductivity standards. The connection to the water main must be made with listed connectors that are appropriate for copper and the water pipe material to prevent galvanic corrosion. The water pipe itself should be metallic and provide a continuous electrical path to the earth. If the water pipe is non-metallic or has insulating sections, a supplemental grounding electrode, such as a ground rod, must be used in conjunction with the water pipe electrode. All connections must be accessible for inspection and testing, and they should be protected from physical damage. The path of the grounding electrode conductors should be as short and direct as possible, avoiding sharp bends and unnecessary lengths. The grounding system should be designed to minimize impedance and provide a low resistance path for fault currents to flow back to the source. This will help to ensure that overcurrent protection devices operate quickly and effectively to clear faults and protect people from electrical shock hazards. It is essential to coordinate the grounding system with the overall electrical system design to ensure that all components are compatible and that the system functions as intended. This includes considering the size and type of overcurrent protection devices, the size and type of conductors, and the bonding and grounding requirements for all equipment and enclosures. The grounding system should be documented thoroughly, including detailed drawings, specifications, and test results. This documentation will be helpful for future maintenance, troubleshooting, and modifications to the electrical system. The design and installation of a grounding system should be performed by qualified professionals who have the necessary training, experience, and knowledge of electrical codes and standards. It is important to choose a reputable contractor who has a proven track record of providing high-quality workmanship and customer service. The grounding system should be inspected and tested by a qualified third-party inspector to ensure that it meets all applicable codes and standards. This inspection will help to identify any deficiencies or problems with the grounding system and ensure that they are corrected before the system is put into service. The owner or operator of the electrical system should be responsible for maintaining the grounding system in good working order. This includes performing regular inspections, testing the grounding resistance, and repairing any damage or corrosion to the grounding electrodes, conductors, or connections. A well-maintained grounding system is essential for ensuring the safety and reliability of the electrical system and protecting people from electrical shock hazards. Grounding is a critical aspect of electrical safety, and it should be given the attention it deserves. By following the National Electrical Code, local codes, and other relevant standards, you can help to ensure that the electrical system is properly grounded and that people are protected from electrical shock hazards. Always consult with qualified professionals for specific applications and to ensure compliance with all applicable codes and regulations.